All right, everybody. Welcome to lesson number 2, title, Normal Distribution. Again, we're basically reviewing the concepts that we talked about in lesson 1. We're just doing more like real-life scenarios and determining more probabilities using that normal CDF button on our calculator and just getting comfortable with normal CDF. So let's jump right into this opening exercise. So it says SAT scores were originally scaled so that the scores for every section were approximately normally distributed. As soon as I see those words, I know that we are going to probably use normal CDF in my calculator. It says the mean is 500, the standard deviation is 100, and assuming that the scaling still applies, find the following probabilities to the nearest thousandth. So it says determine the randomly selected student scores more than 700. So if we are talking about a normal distribution, we want to figure out the z-score that represents 700. So if we're talking about a z-score, the value here is 700 minus the mean, 500, divided by the standard deviation of 100, we are talking about a z-score of 2. And we want to figure out more than that, so we want to figure out all the way up to a z-score of 10. So the lower z-score in our normal CDF is 2. The upper z-score we'll put in 10. Just as a refresher, how we find that in our calculator, we're going to hit second, vars, go to option 2. Remember, it's always option 2. The lower z-score we said was 2. The upper z-score was 10. Go down here and hit paste, hit enter, and we have our number. So we're going to take that number 0.02275. So we'll say 0.02275. All right, so we have this decimal in our calculator, so we can say the probability that our z-score is greater than 2 is going to be 0.023. We'll round up to 0.023 for the nearest thousandth. So we're just showing now that it's a probability. That's all this is saying. It's just notation for saying the probability the z-score is more than 2. Let's take a look for another question here. So it says in 2012, the mean SAT score was 514 and the standard deviation was 117. And it says that it was, again, normally distributed. So again, we want to use normal CDF here. So we want to know what is the probability that that student scores between 600 and 700. So to find the z-score for 600, we would say 600 minus the mean, 514, divided by the standard deviation, 117. This is probably not going to be a nice number, so let's see what it is. So if we divide those two numbers, we get a random decimal. I want to change that to a fraction if I can. So I'll say 86 over 117. I want to try and not round if possible. I know in the previous lesson we rounded like 4 decimal places. It usually won't make a difference, but let's just try and not round if we can. Let's find the z-score for 700. So we'll do the same subtraction of 514, not 15. That was a silly mistake. Divided by 7 at 117. This is probably also not going to be a nice number. So we wind up getting a fraction here of 62 over 39. So when we make my bell curve, we are going to have two numbers that are above the mean. So we'll have a number here of 86 over 117, and the upper number is going to be 62 over 39. How do I know which one's upper or lower? 600 smaller than 700, so I kind of know that. So this is my lower z-score. This is my upper z-score. The nice thing about calculators is we could type it in just like that, right? So we don't have to worry about anything crazy in there. So we just have to type that in just like that. So when we go to our graphing calculator, we'll normal CDF this, go second vars, option 2. The lower number was 86 divided by 117. The upper number was 62 divided by 39. Nice thing is you don't have to worry about it. The calculator does all the work for you. So we get 0.175. So we can say the probability that the z-score is between 86 over 117 and And 62 over 39 is, what did we say it was? 0.175. Again, this is just notation that says I want to find the z-score that's between these two numbers. Number one in the actual notes here, not the opening exercise, says in 2012, Cornwall Central High School had 310 seniors. How many of these seniors will we expect to score between 450 and 650 on their math section of the SAT? So taking a look here, so in 2012, we can find the z-score here for 450. We'll use this 2012 data, so there was an average of 514 and a standard deviation of 117. So if I do 450 minus 514 divided by 117, I'm going to get a nasty decimal. Let's change that nasty decimal to a fraction if we can. Yay, negative 64 over 117. This becomes my lower z-score. The upper z-score we're going to get by doing 650 minus 514 divided by 117. This should come out positive. 650 minus 514 divided by 117, probably not a nice number. It's not. And it just becomes 136 over 117. So what are we trying to figure out here, right? We're trying to figure out the percentage of people that are between these two z-scores. So if we go to a normal CDF in our calculator, second vars normal CDF option 2, so we wind up having our numbers here. I forgot the first one, negative 64 divided by 117 and 136 divided by 117. Hit enter. And we get 0.585. So we'd say the probability that the z-score is between negative 64 over 117 and 136 over 117 is 0.585. So there's about a 58.5% chance that if you were a senior in Cornwall Central High Schools that took the SAT, your score is between those two values. That's what we're figuring out here. Why we're figuring out what proportion of the data falls between these two. So what's the probability of landing or getting a score between those two values? Number 2 says a swimmer named Amy specializes in the 50-meter backstroke. Good for Amy. In competition, her mean time for the event was 39.7 seconds, and the standard deviation was 2.3. Remember, standard deviation is how far apart all of her data is going to be spread. So the bigger the standard deviation, the more spread your data is going to be. The smaller your standard deviation, the closer your data is going to be to the mean. Says approximately normally distributed time, so we know we're talking about a bell curve here. Find the probability to nearest thousandth that Amy's time is between 37 and 44 seconds. So the z-score for 37, so we'll say 37 minus 39.7 divided by the standard deviation of 2.3. This is probably not going to be nice, which is fine. So we wind up getting this decimal of negative 27 over 23. The z-score for the upper number, the 44 number, right, we're still using the same mean and the same standard deviation. We're just going to get a different number. 44 minus 39.7 divided by 2.3. This is just calculator work. You can definitely use decimals. If you don't like the fractions, use the decimals. I like the fractions because it makes sure that I get the exact answer, right? So we have negative 27 over 23 and positive 43 over 23. Now, we're trying to find this percentage. This is our lower number. This is our upper number. So go ahead, type it in your calculator, see what you get. I'll type it in mine. So normal CDF, negative 27 over 23. Positive 43 over 23. Hopefully you get the same answer as me. And we wind up getting the probability of between these two z-scores is 0.849. Hopefully you got that answer. Next, it says find the probability to nearest thousandth that Amy's time will be more than 45 seconds. So more than 45 seconds. Let's first find the z-score for 45. So if we do 45 minus 39.7 over 2.3, we get this z-score. 45 minus 39.7 divided by 2.3 is 2.3 something. Big number, right? So we have 53 over 23. So we're talking about this bell curve. Wow, that does not look like a good bell curve. So we're talking about the bell curve here. This number, 53 over 23, is kind of towards the top. So this should be a small percentage, right? Think about it. If her average time is 39.7 seconds and she has 45-second time, that's a pretty slow time, right? So we want to be above this because it says is more than 45 seconds, right? The words are important here. So the upper number is 10. The lower number is 53 over 23. So here's your lower number, and we'll use a 10 for the upper number. So go ahead, type it in your calculator and see if you calculate the probability the z-score is more than 53 over 23. I'll do along with you. So we'll make the lower number 53 over 23, the upper number 10. If you want to do more than 10, you can. It doesn't really matter. And we wind up getting 0.011. It says nearest thousandth, so we'll round to there. It's 0.0106, but the 6 rounds off. So there's your answer. Find the probability to nearest thousandth that Amy's time is less than 36 seconds. So let's find the z-score for 36. So 36 minus 39.7 all over 2.3. Again, these are all going to be not nice numbers. That's okay, right? Calculator does all the work for us. We get a not nice number. So we get negative 37 over 23. So when we're talking about this, we want to find the percent that is smaller than that. So our lower number is going to be negative 10. This winds up being my upper number. So we're finding the probability that our z-score is greater than, oh no, I put the wrong symbol there. That should have been, oh, that's greater than. This one I put the wrong symbol on. Is less than negative 37 over 23. Sorry, I'm rambling. So we want to find the z-scores that are all smaller than that. So if we do our normal CDF, negative 10 for the lower number, the upper number will use negative 37 over 23. Make sure you put the negative in, that makes a difference. And this becomes 0.054. Number 3 talks about men's shirt sizes. So it says men's shirt sizes are normally distributed. It tells us that the mean is 15.7, standard deviation of 0.7. And the retailer sells smalls, medium, larges, and extra larges, and each one has a neck size. So smalls are between 14 and 15 inches, mediums are between 15 and 16 inches, and so forth and so on. So it says the manager is planning on selling 550 shirts this weekend. Oh no. 550 shirts this weekend. How many mediums should he order? So for mediums, we want to be between 15 and 16. So we want to find the probability the z-score is between 15 and 16. If I can do that, I then know the chance, so I can multiply the chance by 550 and figure out how many shirts he should order, right? So if we want to figure out this, we need to find the lower z-score. So we need to find the z-score for 15. So I'll do 15 minus the average 15.7 divided by the standard deviation of 0.7. So that's going to be, I think, negative 1, but I'll check it. 15 minus 15.7. Yes. So we have negative 1. The upper z-score is going to be 16 minus 15.7 over 0.7. So if I do 16 minus 15.7 divided by 0.7, so I have 0.3 divided by 0.7, I get a nasty decimal, which is just 3/7. So I want to find the probability that my z-score is between these two numbers, right? So we could even convert this and say, what's the probability the z-score is between -1 and 3/7? Now that I actually know the z-scores that I want to plug in. So here's my lower number, here's my upper number. So if we plug this in, second vars, make the lower number -1, the upper number 3/7. I have 0.507. So of the 550 shirts that this manager is going to plan on selling, 50.7% of them are going to be mediums. So if I have 550 shirts and I multiply it by 0.507, I'm going to get an approximate number, 550 times that answer we got before. So we have 278.9 shirts. So he should probably get 279 shirts that are in the size of medium, because that's what the data is telling him to order. About 50% of the shirts he's going to sell are going to be mediums. Number 4 says, suppose that the durations of high school baseball games are approximately normally distributed with a mean of 105 and a standard deviation of 11. Again, normal distribution tells me that it's subconscious at this point, normal CDF in your calculator. Find a final probability near its thousandth that a randomly selected high school baseball game lasts more than 120 minutes. The z-score for 120 minus 105 divided by 11. So that's not going to be a nice number. 120 minus 105 divided by 11, not a nice number. We'll just go with 15/11. That's good. Now we want to see if it lasts more than that time. So when we make my bell curve, I have 15/11. I want to figure out more than that. So the upper z-score is going to be 10. So we can find the probability that my z-score is more than 15/11. So we could go second, normal CDF, make the lower number 15/11 and the upper number 10. So we get a 0.086 chance. Now it says find the probability, so we are done. We can extend this question and say, what if we played 30 baseball games? How many approximately would there be that last more than 120 minutes? Or there's 80 games. So all you're really doing there is one added algebra step. Okay. If you understand how to do normal CDF, you're in really good shape here for these first 2 lessons, and that's all we really need to get out of it, right? Know how to use the calculator, know what the data is telling us, and know what the question's asking, right? Just be careful with the words. Other than that, good luck, and hopefully I see you